Hello everyone, today's topic is time independent Schrodinger wave equation. So for the particle of mass m moving with velocity v, particle of mass m, if it is moving with velocity v, the wavelength associated with that particle as per the de Broglie hypothesis is given by lambda is equal to h by mv, where h is Planck's constant. And the equation, it is as per de Broglie hypothesis. So if a particle of mass m which moves with velocity v as per the de Broglie hypothesis, the wavelength associated with that particle is given by h by mv and h is Planck's constant. So now if we have to solve the situation, the physical situation of the particle, we have to solve the psi, means the wave function. So for this I have already explained about the wave function, which is given by psi is equal to a exponential of minus I omega t minus kx. Here we are using capital psi. Capital psi means this psi is both function of the position and the time. Psi is the function of position as well as time. We have introduced this term as capital psi. As I have already explained, in time independent Schrodinger wave equation, if they take the physical situation of the particle, the amplitude remains constant with time. So here if this equation is for the particle which is moving in the particular positive x direction. So psi is equal to a exponential of minus I omega t minus kx, where a is amplitude, omega is the angular frequency, k is propagation constant. Now what we have to do to solve the time independent Schrodinger wave equation, as we understand that it is independent of amplitude remains constant. So here we have to first separate out the time term and the position term of the equation. So we will separate out the time term and the position term. We get psi is equal to a exponential of minus I omega t, and psi here exponential of minus I into minus kx, minus minus plus. So you will get exponential of plus I kx. This is as per how we separate. If exponential of a minus b it is there, then we can write it as exponential of a into exponential of minus b. And if the base term is same, again the exponential function, it will get added or subtracted based on the sign of the exponential value. So now we consider a So now we'll rearrange the equation. And further write it as so now we have equation psi is equal to small psi exponential of minus I omega t, equation number 3. So again repeating, this psi is function of x and t and small psi is the only function of, so capital psi is both function of x and t and psi is the only function of x. Now further what we will do, will differentiate this equation 3 twice with respect to x and with respect to t. So first when we differentiate with respect to x, what we get, let's see. So differentiating equation 3 with respect to, so differentiating above equation 3 with respect to x, we get dou psi by dou x, that is equal to dou psi by dou x exponential of minus I omega t. Remember, we are partially differentiating the equation 3, once with respect to x and then with respect to time. So as we differentiate the x term, we will leave the time term as it is, and if we differentiate the time term, we will leave the position term or the term which includes the position as it is. So differentiating first with respect to x, we get dou psi by dou x is equal to dou psi, this is only function of x, by dou x into exponential of minus I omega t. Let us consider this is equation 4a. Now further we will differentiate again the equation 4a with respect to x, we get dou square psi by dou x square is equal to dou square psi by dou x square, and again exponential of I omega t we have to retain as it is. Now further we will differentiate equation 3 with respect to time. So when we differentiate with respect to time, we have to leave the psi term as it is and we have to differentiate the term exponential of minus I omega t. So let's see. So we get, so differentiating equation, so differentiating equation 3 with respect to t, we get dou psi by dou t, that is equal to psi, it will remain as it is and will differentiate exponential of minus I omega t. So differentiation of any exponential term, how we do it? If suppose it is 2x, then the differentiation of exponential of 2x, it will be 2 into exponential of 2x. What is the constant multiplied by the function, that will be multiplied with the exponential and the term will remain as it is. So here what we get, if we differentiate exponential of minus I omega t, then minus I omega is multiplied with t. So what will minus I omega will come in the with the multiplication and will retain the term as it is. So what we get? Minus I omega exponential of minus I omega t. Again, so differentiating again equation 5a with respect to t, we get dou square psi by dou t square, that will be equal to psi we have to retain as it is, and again minus I omega will come to the multiplication and will get minus I omega whole square exponential of minus I omega t. Now further we will solve this. Psi, we know I is a complex number, I have already explained, and this is equal to square root of minus 1. So if you square I square, you will get it as minus 1. Now square of minus is again minus minus plus, we get equation as omega square. Square of minus plus I square, it will be minus 1. So this will be minus omega square and will retain the term exponential of minus I omega t. So finally we can write this equation as dou 2 psi by dou t square, that is equal to minus omega square exponential of minus I omega t into psi. Let us consider this is equation 5b. So one step we have completed. We have considered the wave function equation, that is psi is equal to a exponential of minus I omega t minus kx. We have separated the position term and we have separated the time term. Once then we have considered the position term, that is a exponential of plus I kx is equal to psi. This psi is only function of x, and later we have differentiated the equation with respect to the position means x and with respect to time. So we get the two equation dou square psi divided by dou x square is equal to dou square by dou x square exponential of minus I omega t, and the double differentiation of the equation 3 with respect to time gives dou square by dou t square is equal to minus omega square exponential of minus I omega t into psi. Now when the particle is moving with the velocity v, the mass of the particle is m and it is moving with velocity v, and in the time independent Schrodinger wave equation we are solving for one dimension. So the time independent Schrodinger wave equation, as I have already explained, the amplitude remains constant with time. So it is almost equivalent to the equation of travelling wave as per the wave theory. So what is the equation of the travelling wave in the wave theory? It's dou square y by dou x square, that is equal to 1 by v square dou square y by dou t square. So this equation, the above equation represents the travelling wave equation in the wave theory, where the velocity of the wave is V, y is the vertical displacement and x is the horizontal displacement. So, if we are solving for the particle, the microscopic particle with which the wavelength is associated. So, as per de Broglie wave, as I have already explained, lambda is equal to h by mv and v is the velocity of the particle. So, if we take the analogy of the travelling wave in the case of wave theory, where the amplitude remains in constant, and in the time independent Schrodinger wave equation, as the amplitude is constant, by the analogy will replace y by psi, the wave function. We have replaced y by psi, taking an analogy that the amplitude in this case remains constant with time, as in the case of the equation of travelling wave in the wave theory. So, now what we have to do in equation 7, we have to substitute equation 4b, which gives the value of dou square psi by dou x square, and equation 5b, which gives the value of dou square psi by dou t square. So, replacing what we get. So, by substituting the value of equation 4b and 5b in equation 7, we get dou square psi. Now it is small psi, it is only function of x. The equation 4a gives the equation 4b gives the value of dou square psi by dou x square. This psi is both the function of x and t. Now here, when we substitute the value, the right hand side of the equation was the only function of x. The psi was only function of x. So, what was the value? Dou square psi by dou x square was equal to dou square psi by dou x square into exponential of minus I omega t. We will retain 1 by v square as it is, and we will substitute the value of dou square psi by dou t square as is in the equation 5b. It is equal to minus omega square exponential of minus I omega t into psi. While solving, most of you, what you do mistake, when you differentiate the function equation 3 with respect to x, then you differentiate the time term as well. Please don't do. We are doing here the partial differentiation. Once we have to differentiate with x, and the either time we have to differentiate with respect to time. So, when you differentiate with respect to x, don't differentiate the time term, and when then you differentiate the time term, don't differentiate the x term. So, we in this equation what we observe that exponential of minus omega t and exponential of minus omega t both are common term in the either side, and hence it will be cancelled out. So, what we get the equation dou square psi by dou x square is equal to minus omega square by v square into psi. We'll get dou square psi by dou x square is equal to 1 by v square minus omega square into psi. So now what we know that omega is equal to 2 pi nu, where nu is the frequency. Omega is the angular frequency and nu is the natural frequency of the wave, of the de Broglie wave. And so what we will get? Omega square is equal to 4 pi square into nu square. Substituting this in the above equation, we get dou square psi by dou x square is equal to minus 4 pi square nu square divided by, here what we know that v is equal to nu lambda. We know this equation, we have already studied. Velocity is equal to frequency into wavelength. So if we square it, we get v square is equal to nu square into lambda square. So substituting this, we get for v square, we can write it here nu square into lambda square and into psi. Here nu square is in the numerator and the denominator as well. It will be cancelled out, and what we get, dou square by dou x square is equal to minus 4 pi square divided by lambda square into psi. What is our objective? Here is to find out what will be the equation in terms of wavelength. So we will simplify the equation further and we get 1 by lambda square, that will be equal to minus 1 by 4 pi square 1 by psi dou square psi by dou x square. Remember, don't cross multiply the differential term, it is one complete term. You cannot will not multiply dou x this side or either side. It is not cross multiplication. You have to retain the term dou square x, you have to retain the term dou square psi by dou x square. Now this is equation 8. So we have come to the equation for the wavelength, the de Broglie wavelength. Now this is the second step what we have completed. First step, we have differentiated the wave function with respect to x and with respect to t twice. We got the function dou square psi by dou x square and dou square psi by dou t square. We have considered the travelling wave equation, and by analogy we have now our own stationary or the travelling wave equation, which is dou square psi by dou x square 1 by v square dou square by dou t square. We have substituted the differential value and we have arrived to the wavelength equation, that is 1 by lambda square is equal to minus 1 by 4 pi square 1 by psi dou square psi by dou x square. Now further, our objective is to find the energy value of the particle. So first we will find out the kinetic energy and then we will consider the total energy to solve the equation to achieve time independent Schrodinger wave equation in one dimension. So the kinetic energy of the particle, it is given by half mv square, where m is the mass and v is the velocity in x direction. So further we will simplify the equation, we will multiply the right hand side of the equation, numerator and denominator both by m, we get m square we get m square v square divided by 2m. Now what we know, the momentum of the particle is given by P is equal to m into v. So what we can write it, this as P square by 2m. Again what we know, lambda is equal to h by p, means de Broglie wavelength equation is given by h by p, where h is Planck's constant and p is the momentum, which is equal to m into v. I have already discussed while starting of the derivation. So if we substitute the value of p, that is p square, you will get h square by lambda square. So here h square by lambda square by 2m. Kinetic energy is equal to h square by lambda square 1 by 2m. So what we know, we have already derived the lambda equation. What is the lambda equation? 1 by lambda square is equal to minus 1 by 4 pi square 1 by psi into d2 psi by dx square. So we will substitute the value over here, we will get minus h square by 4 pi square 1 by psi 1 by 2m into d2 psi by dx square. We can write it 2m later also, I have written it first only here. We have substituted the value and further simplifying, what we get, kinetic energy is equal to minus h square 4 into 2 8 pi square m 1 by psi d2 dou square psi by dou x square. This is the equation for kinetic energy. Kinetic energy is equal to minus h square 8 pi divided by 8 pi square m into 1 by psi into dou square by dou x square. So now we have to find out the total energy of the particle. So if E is the total energy, and V is the potential energy, then E will be equal to, the total energy will be equal to the kinetic energy plus the potential energy. So substituting the kinetic energy value, we will take it as equation 9. In this equation, what we get, E is equal to minus h square by 8 pi square m 1 by psi dou square psi by dou x square plus v. Now further we will simplify this equation. We get E minus V is equal to minus h square 8 pi square m 1 by psi dou square psi by dou x square. Now we will cross multiply, we will take at 8 pi square m psi to the numerator of the left hand side and h square will divide it. We will leave dou square psi by dou x square in the either side itself. What we get, 8 pi square m by h square E minus V, and psi, instead of writing this side, we'll write it later. Psi will be equal to minus dou square psi by dou x square. 8 pi square m divided by h square e minus v psi is equal to minus dou square psi by dou x square. So finally what we get, dou square psi by dou x square. Now or this term dou square psi by dou x square, it is with negative. When we bring in the left hand side, it will be positive. So plus 8 pi square m divided by h square e minus v psi, that will be equal to 0. So this is equation 10, and equation 10 represents one dimensional time So equation 10, which is dou square psi by dou x square plus 8 pi square m by h square e minus v psi is equal to 0. This represents one dimensional time independent Schrodinger wave equation. You will be asked with the question, set up time independent Schrodinger wave equation in one dimension, or it can be asked, set up one dimensional time independent Schrodinger wave equation.